All set? Okay, good morning. Welcome, everybody. Welcome back to day 2 of the Aerospace Village Theater. The crew has a lot of exciting content for you today. We are happy to kick off day 2 with all Hackasat updates. I am very, very proud to tell this entire room that we have successfully completed and accomplished a space challenge using our on-orbit satellite, quite literally making us the world's first CTF in space. So, thank you. Big props to our team out there, the game ops, the satellite ops, and of course all of our competitors. And thank you all for being here with us today. So we do have a lot of very exciting content. Jordan is going to fill you in all day yesterday. It was very productive, and even overnight, our teams were continuing to downlink data from the satellite to parse through all the information that came through. So there's a lot of really exciting information to share with you all today. Before we do so, just in case anybody wasn't around or hasn't had the background of Hackasat, we do want to get started with just a quick video, a good overview of where we are, who we are. So let me get that going for you now.
The problem is really quite simple. Find the best path to get from point A to point B.
The United States Air Force and Space Force had an idea to host a space-based CTF to advance space cybersecurity. While many were sure it couldn't or shouldn't be done, in 2020 they launched Hackasat, an educational effort and capture the flag style hacking competition. Hackasat is designed to inspire the global security researcher community to develop the interest and skills necessary to reduce vulnerabilities and build more secure space systems. Education has been central, from testing the public with an open hacking challenge, to a tough qualification round introducing space-relevant topics and skills, to a set of hands-on workshops in the virtual Aerospace Village at DEF Safe Mode, to a whole library of resources on space and hacking. We developed flat-sat hardware and challenges to give security researchers access and experience to space technologies they wouldn't have otherwise. It all led to a fierce final CTF competition for the top 8 teams from quals, and the source code for all quals and final challenges are available on GitHub for the community to keep learning. As Hackasat 1 ended, planning started for Hackasat 2. We enhanced the Hackasat FlatSat and assembled a new digital twin to support even more realistic space challenges. The qualification round took place in June 2021, with the top 8 teams making it to the final event. Hackasat brought a full slate of talks and workshops about space security to DEF CON 29, and the virtual final CTF took place in December 2021. Challenges were still based on the FlatSat, but now teams could test their commands within the digital twin simulation. And again, the source code from quals and finals challenges are available on GitHub through our Players Corner page. As Hackasat 2 ended, planning started for Hackasat 3, and development was already well underway for Moonlighter, a 3U CubeSat dedicated to furthering space cybersecurity. Its first mission would be to host Hackasat 4. We developed the digital twin-based final event to mirror the actual Moonlighter satellite. And with help from astrophysicist Dr. Hakeem Oluseyi, we built an online educational experience for the public to plan, build, and test their very own 3U CubeSat, just like Moonlighter. Hackasat 3 quals took place virtually in May 2022. In August, the Hackasat team brought space-relevant talks to Aerospace Village at DEF CON 30. The finals took place in October of 2022, with 8 teams working through 12 challenges over 23 hours in this attack-defend-style CTF. And again, source code from quals and final challenges are available on GitHub. As Moonlighter moved from design to the build stage, the team went deep into Hackasat 4 planning. A space-focused CTF is hard to build and play. An on-orbit CTF is even harder, and it's never been done before. Our qualification round took place April 2023. Moonlighter launched on June 5th.
1, ignition.
And deployed from the International Space Station on July 6th, and is now in low Earth orbit. This is its first mission. Practice is over. The Hackasat 4 final event has begun.
A huge congratulations to the Moonlighter team. Stay in touch and best of luck with operations.
Awesome. Thank you. So now that you know, definitely, we're Hackasat. We're excited to be here. But more importantly, DEF CON's no stranger to CTFs, right? But a space CTF, this is new. This is exciting. So we do want to provide to you, before we get into all the details of how yesterday unfolded, here's a quick game explainer, and then we'll get Jordan up here to get all the details for you.
5, 4, 3, 2, 1, 0. All right, lift off and the clock has started. The great challenges of our age, here on Earth and beyond the Earth, in space.
All right, everybody. All right, everybody. Good morning. Can you hear me? Hold on. We'll get this mic going. I can yell, but I don't want to lose my voice, so let's try again. Is this? We'll use this one. We'll use this one if it comes on. There we go. Which will be tricky as I have to type one-handed later, but we'll figure that out. So, good morning, everybody, and I'm excited here to talk about the details of the capture flag, kind of what's been happening, give you an update here. I'm Jordan. I'm the sort of CTF sideline reporter, so my job is to dig into what's been going on, talk about the challenges. It's a nerve-wracking update, right? Because at the beginning, we sort of know what we're going to talk about. We can't talk about the challenge. We're going to talk about the beginning of the game. This middle update, we can only talk about things that are already all solved, or we can talk about scoring events, and then at the end, we can talk about all the details. So we can go into the behind the scenes of all the challenges and whatnot. So this update is the scariest because you don't know if you're going to have things to talk about. Are the teams going to score? Will there be things you can talk about? What will have happened? Thankfully, we've got a whole bunch of stuff to talk about, so that's a relief. I was excited to have that happen. Just as a reminder, this is kind of the overall structure of what the teams have been doing, right? So in the lower left, we have the teams. How many people saw our update yesterday, by the way? If you were here yesterday morning, good. Okay, if it's a mostly new audience, then I'll make sure we're all up to speed at the same time then. So in the lower left are all the teams. They're here in the other room through that wall. You can see 5 teams that have made it here into the finals. They're talking to the satellite through this tasking API. They have this web server interface that all of their code gets uploaded to, all their downloads come through, but then those go to this validation system that actually will check all of their submissions, make sure they're well formed, and then it goes into the command scheduler, and that's all kind of done through the infrastructure from the game team here, but then the command scheduler goes into the KSAT ground link network. And so there's actually a commercial provider of satellite ground link stations. We've got 4 locations throughout the globe. And then the next time the satellite is over top of one of those, there's a whole set of like commands that are uploaded and data that's downloaded, right? And you'll notice though that the ground station, the ground network that goes up is different than the ground network that goes down. Now, they're the same thing, right? It's the same 4 locations. The difference though, oh, sorry. All right, is that better? All right, let me know in the back if I'm getting too quiet. I hear my echo, so. The ground network, the same 4 ground stations that uplink also downlink, but the point here is that they don't do it at the same time, right? So if I upload something to happen, it happens sort of over the gap between the communication windows. So the code all gets queued up, it's on the satellite, and then it gets run while that satellite is going until the next communication window, then it downloads all the results. So there's a lot of lag, and even beyond that, and because some of these windows can be quite long, even beyond that, when you have an especially long window between the communication, you can't even download all of the telemetry, all of the things that have happened that have run on the satellite. And so it's this very like fluid environment where it may take multiple contacts to download what happened 2 windows ago, for example. And so there's a whole lot of things that you've got to kind of juggle and deal with. And you've got noise. We've had contacts that were interrupted by just bad RF, where the communication link couldn't happen because it was just too noisy of a signal between our ground station for whatever reason. There's a lot of things that are out of our control. And so that can really make a lot of this challenging. So the data comes back down on the next pass for whatever attempt you made, whatever challenge you tried to solve, goes through the ground network into the telemetry data that goes back into the teams, and they get to evaluate kind of what they did. So this is the sort of like overall look where you can see the windows that teams have are not fixed, right? And these are determined by the physics of the orbit. We didn't even know, in fact, the exact details of when we would have access to the satellite until this week. It's really been rather, sort of sudden in terms of trying to figure out now how does this impact the challenges? How many times can the teams talk to the satellite? So you'll see even, for example, today, there's very few contact windows. We really only have 2 contact windows the teams can queue up their commands to the satellite. And so it means that you better get things right? There's not a lot of room for mistakes. And then a lot of these contacts do happen after hours, though. So the good news / bad news is that, as I said, in these long windows, it takes a while to download all the data, but we've got more windows. And that's also why we're not really announcing the winners, because we don't know the winners until much later tomorrow morning when we've pulled all the data, we've combed through all the results, and we can really see what actually happened. So even the scoreboard that we're going to show is not actually real, right? In the sense that there's probably things that have happened since then that just haven't been downloaded or haven't been processed. There's multiple stages that are happening in this. So it's a kind of long tale before you find out about some of these things happening. Specifically though, you'll notice that teams can interact with these windows in sort of 3 primary ways. The first is they can upload a script, they can run a script. The second is that they can use the scripts to take a picture. There's an imager, there's a camera on Moonlighter. And the third thing is they can downlink some of that data. They can download results back out. In fact, it's up to them then to figure out what they're going to do throughout all of these windows. You'll notice, so yesterday again was the start of the game. Teams had the beginning of their access then, and there's these 2 windows, those little kind of white blocks of the communication windows, very, very quickly. All right, and so the teams wouldn't have been able to get a whole lot done then. Turns out they couldn't even communicate with the satellite at all. We actually unfortunately had 2 errors that resulted in these windows kind of being unavailable. One was due to some testing infrastructure because unlike a server where you can have 2 servers, and one's prod and one's testing and they can be identical, well, it's a satellite in space, so nothing is identical. And so some of the testing infrastructure that was in place sort of blocked the upload to the satellite during that first window. And so unfortunately we lost that opportunity. And then the second window, again, we're at the sort of mercy of our ground network operator. They just dropped our connection, essentially. We don't really know. Sometimes it happens. You lose access to these windows. So those 2 windows didn't actually even happen. Teams had queued up commands. The good news was we looked through the results. None of the teams lost scoring. Nobody had anything that was going to be a solution that would have actually scored on any of the challenges. Awesome. Let's see if this one works. Let's try this one. Can you guys hear me now? Still a little quiet? Oh, there we go. They're going to bring me up. Perfect. All right. Thank you. So the teams here they missed a couple of little sort of learning opportunities, right? These could have been good chances for them to be able to like find out how things worked. And so, for example, one thing that happens is that all the telemetry and the log data that comes back is shared with all teams. So this is kind of an interesting like twist, right? Like you as a team, if you run a script and there's some output, everyone can potentially see that. So teams had to account for that, and we wanted them to learn that in these sort of first 2 windows as they were sort of testing the earlier like tests. But because they didn't have that opportunity, what we did was we essentially on the 3rd window, when any data came, or the next window that came back to teams where they first had data back, we said, we're separating your logs for this run once, just because you didn't know, so everyone got their own logs separately. But just so you know, from now on, your logs are coming back with everybody's, right? So they have to kind of account for that as they're participating in the game. This is a concept called consensus logging or consensus evaluation. It was actually kind of popularized in Capture the Flag a few years ago at the DARPA's Cyber Grand Challenge, where it was one of the first major Capture the Flags where everything you did, every change you made to your environment, every team got to see. And it really changes the playing field, right? It's a very different game when I submit a change to a binary, I try to patch or make a fix, if other teams can see what I'm doing. It's sort of, you have to account for that in terms of how you play the game. And this is kind of a really interesting trade-off that exists in the real world too, because sometimes you can keep things secret from attackers. Sometimes the attackers don't know what kind of infrastructure you're running. I mean, sometimes they do. Like they can download Windows, they can download the antivirus software you're using, and they can analyze it. They get full visibility into some of the things on your network or some of the software you're running. And so it is this interesting trade-off that you see in Capture the Flag events where they try to balance between, like, is it realistic, is it not? And consensus evaluation is one of those things that absolutely exists in kind of the real world too. So after those windows, we have a couple more kind of windows later on where teams really start getting into it. They start uploading their attempts, and we start seeing what they're doing. Let me go to this actual score chart, and let's talk about this too. Right, so our scoreboard here has all 5 teams, and we had to update this right before the talk because again we had some scoring events that came through, and again, this is itself even delayed, right? So we got this update, all the data was coming through, but we don't actually know if this is the current sort of state of reality. We have to let everything kind of settle out, and we'll find out later. The five teams we've got. So you see, at the last minute, Poland Can Into Space has jumped into first place, and then tied for second place we have Jump FS and Space Bits Are Us. And we've got in 4th place Krautset, and then Macaroni, or M Hackaroni, and in the 5th place Spot Now. But again, there's a lot of room for teams to jump down, because you can see, like, one update could bring you, several spots up pretty easily, because there are a number of challenges that are left. Let's go ahead and talk about just the overall kind of score chart. I like this one for looking at what's happening in the game. If you go to our website, again, you can pull up this data. You have to click the plus signs on the left to bring up the little, the key, the legend that shows you which color is which, if you don't remember off the top of your head. But you can see the total points for each one of these challenges. These are the ones that have been solved so far. So this is, as I said, this is nerve-wracking when you're a competition organizer. Just seeing those first solves come in is fantastic and exciting. The top 2 challenges, Password Manager and Flight Software Freebies, these are challenges that existed in our ground network. So they were solved by all the teams because they probably had more time to work on it, and they had just software they could work with and analyze. But these are not necessarily like gimme challenges. I'll show you in much more detail. We can talk about that. So the good news is, because everyone has solved it, we can analyze and we can look at it and we can see what they did. And those are going to be kind of more traditional software security vulnerabilities, binary analysis, decompilation, exploitation that the teams had to do. Because again, that's very much a part of the ground station network. And the satellite ecosystem includes not only the satellite itself, but the ground stations that it's talking to. And so making sure that they're secure is equally as important, because if the controllers are hijacked, well then so can the satellites. And so you'll see, thankfully all teams have solved that. I'm going to go give them a high five on the way out, because that makes my life easier, because we can talk about those. These other challenges we can't go into full detail on, because not every team has solved them, right? So tomorrow, if you come back at the awards ceremony, we can talk a little bit more detail about how they happen, but we can at least talk about the sort of general shape of the challenges, what the teams know about what they had to do. So this 3rd challenge you see here is called Script Kitty, and the idea here is you just have to run a script. Remember I said earlier that there's this command interface that lets the teams upload their code. Like their code is running on the satellites. They're not like sending a packet to the satellite and getting a response back. Everything that they run has to run on the satellite. It's a Lua scripting engine that they're running with, and it's got a whole bunch of access to the imager, to the GPS module, to all these different things that they're writing their code as these payloads, and then they upload it. That's also where I said that log data that comes back from those scripts comes into that log and that telemetry that gets distributed to all of the teams. So we saw 3 teams in the same scoring window were able to score on that script kiddie challenge. We had PFS RCX, or Jump PFS, or Jump as they get called. We had Poland Can, and we had Hackasat all score in the 19th scoring round. So let's talk a little bit too about those scoring rounds, because if you look up top, you'll see there's 1, 2, 3, 4, 5, 6, 7, 18, 19, 20, 21. The fact that they're not contiguous is just sort of an artifact of some kind of internal, some testing that was happening. But the whole point is, this is the rounds as they happen with scoring windows. And so this is not linear, right? This looks nice and linear, and you look here like it happened all, like it kind of like chunked at a time. But those scoring windows, as we saw earlier, if I can get back to them, the scoring windows, as we saw earlier, don't always happen at the same time. You look at those timestamps are a little small. Again, the website has the details, and you can pull them up. But they're not like every hour. They can be very random. They have, actually, this one has the better one, right? You can see the gaps between each of those windows. And so when we talk about these rounds, some of these rounds are rounds that happened last night, but the teams had uploaded the data before they left, and it finally made it up to the satellite. The results happened. We got the data back in a later round. And so that's why you see it sort of like in this nice, pretty regular chart here and here. It's not so clean. It's not so easy in terms of how it actually has happened. So again, script kiddie is your code execution, like running a code. This is part of a normal API. You're allowed to task. You get a time slice. You get to run your script. But then can you violate certain properties? Can you do certain things, or some of these later challenges? So this is sort of, yes, hello world, you can run code. Now go on and actually do something with it. And that's what we're going to see with these next 2 challenges. Silver medal is a challenge of just take a picture. You had to take a picture, and the teams didn't have access earlier in the day yesterday to controlling the attitude of the satellite. So there was only a window of time overnight that they were actually able to adjust the orientation and for pointing. And so if they want to take a picture of a specific place, you have to be able to point the satellite. And so that data is still coming in, and we'll see what they did, and we'll hopefully see some of those images. I'm really looking forward to seeing the first capture the flag picture from space that live happened. We did actually have one a few years ago. So we had called it a moonshot on a previous version of Hackasat, but it wasn't the CTF happening on the satellite. It was like a separate challenge that they could run a little bit of code that was tested, and then their pointing math was uploaded to a satellite and a picture was taken. So that actually let them take a picture. But this is like, no kidding, really. They're writing all the code. They're doing all the orientation on the satellite. Their code's running it and triggering it. So cross your fingers that tomorrow we're going to have some of those coming back, because like I said, from about, I think, 1 a.m. last night until just before we started speaking now was the period of time where the satellite was moving. And partly that's just because the control system is a physical artifact. And so there's actually, it's not like a digital on-off exact pointing mechanism. And the flywheels, the systems that actually do the orientation, require a lot of maintenance and tuning and tweaking. And so there's only kind of a narrow window of time that they can actually do that. Of course, there's also power concerns too. But they've got to kind of reset and adjust the system so it doesn't become usable again. Go talk to all the people that do the real space stuff for the details on how that system works and why they need to kind of reorient it. Because that's, like I said, I'm just a hacker commentator here to talk about the security stuff. So at 11 a.m. is when they had that window to orient. So we'll see what images come down later. This one, as this satellite is spinning, so again, outside of that window I just mentioned, where it's under control and it's actually, they can orient it, the satellite's actually kind of just free floating. Like its orbit is fixed and they know where it is, but it actually is aiming in all different directions. And the teams didn't actually control that, but they could still just take a picture. And so that's what we're seeing here in the silver medal challenge that we have both JumpFS and Poland Can solving. They were able just to take a picture. So we will at some point be able to get that picture. It'll probably just be black or looking at space, so there may not be much to it because again, they didn't control where it was aimed. In fact, one of the teams got bit by a little bit of bad luck. They triggered take a picture, but they were in a region that is what we call like this. We've got banned regions, and this is not actual banned regions. They literally did like bands around the globe. So there's a bunch of longitudes that you can't take a picture of the Earth for. And the idea is that this is, again, one of those exercises they have to solve. So this is one we're not seeing on this view, but this is called unintended bug. And that challenge means you have to take a picture of one of these locations where you're not supposed to be able to take a picture, right? There's code that prevents them from actually taking a picture out of a big chunk of the globe. We'll talk more about that tomorrow, how they had to solve it and how they could do that. But you know, hopefully somebody actually gets that one kind of figured out. And I think they will from something we're going to talk about later. But one of the teams, which is randomly snapping a picture during one of their code windows, they happen to be over a banned region, and they happen to be aimed at the Earth. And so the thing said, no, I'm sorry, I can't take that picture because I'm in a banned region. So it prevented them from actually solving this. So it's unfortunately a little bit of bad luck, but that's going to happen. And they could have maybe controlled it, for example, if they would have calculated where in the window the flat sat would be above one of those banned regions and where it wouldn't. They could have intentionally chosen that. So we'll see if that is something that they can solve or not. They're going to know, though, when they get back the results and they're told, no, your picture didn't get taken. So they already know that's a problem. They've figured that out. We'll see if they can actually solve it, though, already. So the last one that we've seen solves for, again, this is the one that happened just before we came into this event, is called Christmas in August. It's so called because you have to visit the North Pole. What you're supposed to do is have the satellite show up over the North Pole. However, I mentioned yesterday, there's no boosters on this satellite. There's no propulsion. There's no ability to move it. The budget wasn't there for like a fully autonomous vehicle in space that can move around. So how are teams supposed to do this? And the competition organizers did communicate to them, you have to basically get the GPS to be wrong, right? Because there's a GPS receiver on the satellite, and so they have to do something to basically get the satellite to think it's somewhere else. And so that is going to let them, lie and say that they're at a particular location. So two of the teams have figured that out. They were able to use a cool trick that we'll talk about tomorrow to be able to get the satellite to be somewhere else. And they were able to go visit Santa, pick up some cookies, have their Christmas in August, which is that particular challenge. So those are the points that the teams have been able to score. It's a great start, and again, while we only have these two more kind of windows today, the good news is, again, there's still data coming down. There's still a lot of things that we're getting from both that happened kind of overnight, that are happening today, and they're going to happen even over tonight as we continue to process and pull everything out. And so we'll see everything else that's going to happen. I'm going to go through some challenge walkthroughs, though, right? So for those of you that want kind of a little more detail of like, well, what does it mean when you say that they're doing an exploit or they're solving a challenge? Because all 5 teams have solved these 2 ground station challenges, we can take a look at it. We can actually pull them up and show you all the details and talk about what exactly they're doing, and you can see like the kind of what goes into their solving one of these. So the first one is a tool called Password Manager. And this is it's actually, the actual binary name is Final Pass, which I think is kind of a play on words from LastPass, which is a password manager you might be familiar with. And the original idea actually for this challenge was, it was going to be a challenge you had to solve at the very, very beginning before you would use that to unlock a separate server, and then that would unlock to give you all of the binaries for the rest of the challenges, and you would kind of have to solve these kind of sequentially. However, when the organizers looked at the communication windows and they saw how few sort of communication slots there were, they actually changed the challenge up a little bit, made this one a little bit easier, and made it so you can just solve it and it doesn't block your access to any of their challenges. And again, this just comes down to you have to be flexible because the environment you get in space may not be the one that you think you're going to get when you're in planning. And so they actually changed this before the competition started. To be clear, all this is done before anything's happened, and so it's fair. All teams got the same binary, because that's also another really big concept in Capture the Flag, is that anything you tell the teams, you have to stick with it. Anything you communicate has to be even to everyone. Everyone has to have the same kind of scoring opportunities. So let's take a look at the password manager here. And we're going to use a tool called Binary Ninja. Shameless plug, my company builds this product. But it's basically a decompiler, right? So this takes apart and analyzes binary code, turns it back into source code or something like it that you can try to analyze to find out like what the code actually does. And so the font is going to be really small. I apologize in advance. Actually, maybe we'll bring up the font size a little bit and we'll see if we can make this a little bit more readable. But the idea is that this is, again, The code that runs on the satellite or runs on your computer or your phone is just binary, right? And the CPU is going to execute that directly. But what you want to know as a human is, what is this actually doing? Like, can you tell me something meaningful about that? And so tools like Binary Ninja turn that binary back into something understandable by humans. So that's a little bit, there we go, let's go back to the right one. A little bit more readable, hopefully. Like I said, we'll put the videos online so you can blow it up full screen later as well too, so you can see it there. But the idea here is you can just kind of see a bunch of yellow on the screen. So let me talk about that for a second, because when you give a binary to teams, you have a couple of choices as an organizer. You can give them something with what we call full symbols or with debug information, and that basically gives them a lot more data about what's actually happening. You're sort of including some of the stuff from your source code. And so we can actually see that here. We see a whole bunch of C++ namespace symbols. So we have a lot of that included in this particular binary. We see some that are compiled in the binary. We see some that are imports from libraries, like standard IO stream libraries. And so we can start, like, this is the code as it runs, but thankfully the teams had a lot more hints on what this binary is doing, because they can actually kind of read some of the code. We can see here, we know it's called a password manager. We can see it creates this manager object here, and it's got this process choice menu, for example. So we can look at the process choice, and you can scroll through here and you can see, view a password, add a password, delete a password. So yeah, it's a password manager. It's what you would expect. But there's this interesting thing you can do with the password manager, which is that you can load a database. You can actually give it a preformed database, like you have created your own. And so if you got this binary and you can analyze it, you can figure out, what does a valid password database look like for this custom service? And so you would go into there, you would look at what it's doing, and even before you get there, you might see, this is a little interesting. Start DB thread. Like, oh no, this is sort of a dreaded thing. If you've ever done any multi-threaded programming, how many people have written like multi-threaded like code where it's like you've got to deal with different threads? This is actually really, it can be a lot of work. Multi-process, multi-thread stuff, because now you have to worry about race conditions. Now you have to worry about, like, well, you have to have mutexes or loxes, things that control access. So multiple threads are just like running sort of two processes that then talk to each other. Right? And so they can run at the same time, because your computer has lots of CPUs that can run at the same time, so you can run these separate processes, but they increase the complexity of the code a lot. So in this particular challenge, trying to reverse engineer it was pretty easy. Like, you can look at this, all the symbols are there, it tells me what it's doing, I know what libraries it's importing, I can read the start DB thread, it's got a get database from the user, so it's actually going to open a data connection, it's going to parse some database. I have not seen this binary until literally a few hours ago this morning. They showed me this like on the spot when they made it, and this one's pretty straightforward. You can just kind of read through it to understand what it's doing. It's got pretty error messages that you can see right here. So it's, could not have created a user, so there's a problem with the user creation. What the teams had to figure out though was that this, every time they opened up, whichever time they uploaded a file, a new port was open, a new socket was opened, and then they would upload the file to that socket. This is a little bit like how FTP works. If you're familiar with how like the file transfer protocol, when you upload a file, you say, I have a file, I'd like to upload it. And it's like, no problem, send it over here, and it gives you a new port. Most of the time nowadays, like we have websites, when we upload files, it all just uses the same kind of web connection, and we make a bunch of requests over and over to the same connection. So this is sort of a different way of transferring files, a little more old school. But in this case, it hints to teams like something's weird is going on. Like, you wouldn't normally build something like this without a good reason. And in this particular case, if you're able to open a separate connection, and then you can change some information on the server at the same time, you can trigger this sort of like a race condition. So what you're uploading, instead of overwriting your database or your information, you can overwrite something else. And what you would essentially do is you would use this to change your name and become, now I'm an admin. So you would essentially use this trick to become an administrator. What I think is especially interesting about this is a lot of these challenges, a lot of these exploitation challenges, you're looking for memory corruption. Like if you've heard of a buffer overflow, right, where you have a specific size of data and you write too much into it and you overwrite some pointers or a return address, and you're trying to basically get the computer to execute your code instead of the code it's supposed to run, treat your data as if it were code, or you're trying to like hijack the control of where it goes. Control flow hijacking, or remote code execution, right? So this is what we often think of when we think of like the most hardcore capture the flag kind of challenges. And this one, you never get code execution. You don't need to. You just need the password that's in the admin's password database. And you can do that by using sort of this race condition, which is a memory corruption. You're changing bytes you're not supposed to be able to change because it's sort of confused about what you should have access to by having these two different processes running at the same time. And when you do that, all of a sudden you're just an admin and you can now read a password that you shouldn't have had access to, right? So I think this challenge is really interesting that every team solved this, right? Like, I kind of blew through the explanation, but there's a lot of code here. It's a lot to look through. And so these are all very good teams that they would have put this together and essentially done it midway through the day yesterday to be able to like solve this as well as the next one with the resources that they had. So like I said, this one, the exploitation's a little bit tricky. Figuring out how you have to kind of win the race is the phrase that we use in exploitation when there's a race condition. But they did have a lot of symbols. Now the next challenge that they had was a little bit different. I'll just leave it up here in this mode instead of the full screen mode, because the next one is called Flight Software Freebies. So again, you saw on the scoreboard, you can see the names, the Password Manager and Flight Software Freebies. Flight Software Freebies is just a web server, right? And so you can access the web server, and they've actually been using this to send things to teams. They make files available. There's things on the web server. You can see here there's like documentation, there's tasking API information. So this is actually kind of a part of the like how to access the game. All that information comes from this web server, but it's a custom written web server that the teams could actually use a couple different vulnerabilities on to achieve different things. Now again, originally these two challenges, first you were going to have to hack the password manager, get the password, then you were going to have to hack the web server, and that would give you all of the challenges, binaries, the documentation information that you would then use to access the remainder of the challenges. But when they took a look at the windows and how like difficult it was going to be, they said, you know what, we're not going to let this block things. And so at the beginning of the game, all of these downloads were available. So all the teams could get all the files and kind of work in parallel. But they still had to solve this because there's still points behind this challenge. And so there were a couple different ways that teams could do this. The teams were not given, unlike the last one where they just kind of had the binary and they were just given it and told it, here you go, analyze it, here's your password manager. On this particular one, they had to actually figure out how to even get the binary in the first place. And so it turned out that there is there's a couple ways they could do this, but the web server itself had sort of like a web security vulnerabilities. There was an API that you could access. So if we look on this screenshot of it, you can see there's like a server status page, which just includes some random information. One of which, let's see here. Oh no, I went all the way back to the beginning. I hit the wrong one. That's all right, we'll scroll. Sorry, if I turn my head sideways, I think I make noise. So if we look at the server status page, does anybody see anything slightly unusual on this page? Actually, audience participation. I like to do it that way. Let's see. Does anybody? So there's just a bunch of like headers and text. One of the things on the right column has something that's like a little not like the rest of it. Does anybody see it? This is how I know everyone's still awake. It's early, I know, on Saturday. Anybody see anything? So we've got like HAS4 HTTP, there's a server name, there's a document root, there's a bunch of values and true, false, Boolean things. There's this host OS that includes Linux, AWS, includes it's running Ubuntu, a timestamp, and then what's that there at the very end? There's like this long number. And this was sort of like a little bit of a gimme. There's actually a value, that's actually a running pointer, it's a pointer that got accidentally leaked in the server. And so if you're able to download the copy of the server using a separate vulnerability, you can use that to figure out where it's running in memory. One of the techniques that's used in computers nowadays to make your software harder to hack is that the programs are randomized where they run. Like you have memory, you talk about like 8 gigs of RAM in your phone or 16 gigs of RAM or 64 gigs of RAM in your computer. Well, that memory is like a big chunk of memory, and when you load a program into it, it used to be your programs were always loaded at the same place. And so when I wrote an exploit, I could just go to the same place if I kind of hijack control and know what was going to be there. You don't have that nowadays. We have what's called ASLR. We move things around. This lets you beat that. This was sort of leaking information and telling the person visiting the website where this process was running in memory. So by combining that with a separate vulnerability that let them include a local file, pull something out of a proc self, if you really want to go to the geeky details, you could proc self and you can pull out the memory of the current process, and that gets you the bytes of the binary, so they could get the binary and they could get where it was loaded, and that gave them a lot more information for them to access another vulnerability. So we're not going to go into like the full details of exactly how to exploit that vulnerability. We'll save that for maybe a wrap up later. But I do want to show you kind of the difference, because I think it's instructive to like just see, as I said earlier, you could see on this binary we have symbol names. We know that we see a bunch of information. We knew what it was doing. If we pull up the web server, I don't see anything readable here. I see, okay, there's a string, web server starting up, but all of these functions just are a random address. There's no name on them. This is what's called a stripped binary. Because again, the computer doesn't need to know the human readable names. And most binaries don't have any human readable information in them except for like the strings that are going to be sent to users, or if there's things that are part of the program. But the actual code doesn't need that. The code just runs on all the addresses. And so here you can see this is a very different, much harder to analyze binary. And not only is there no symbol information, there's no details about what these functions are doing. This is what's called a statically compiled binary, which means that normally when you call like other libraries, you want to include some other standard pieces of code that every C program might kind of want to access. Like when you do a hello world, you would like print to a screen. You'd say printf or puts or something, and you'd write to the screen. You're not writing all the code to tell it how to write to the screen every time. You just tell it what text to put on the screen. The library that does that code is like a standard library. And here it's all compiled into one giant binary, none of which has names. So that actually makes the reverse engineering of this binary a very different process. And so when I looked at this morning, I was like, oh no, like how would I reverse engineer this? Well, the answer here would be something like you might look into all the strings. You might search the strings and you know it's a web server. So you might look for post, for example, right? Post is an HTTP verb a web server would use. And so I could find that string, okay, let's go look for post. All right, well that gets referenced from this piece of code. So now you'd start from that and you'd work kind of backwards. Whereas the other binary, I could just start from the top and just read what it was doing. I could look at the source code, look at the names. It was almost like reading source code. This is much harder to read and it's much more work. So I really think it's interesting to look at the difference between these two processes, like how you would solve these two challenges are kind of very different, even though they're both just sort of binary challenges. So as a web server, you had this local file inclusion vulnerability. You could read yourself, you could read other files, and the teams could use that to get the flag, or they could access another. There was actually a buffer overflow in the binary with a whole bunch of other stuff beyond that. So again, those are the two easy challenges. Those are the easiest ones. The teams did the quickest. So we're looking forward to seeing what else they can do throughout the rest of the competition. Really quickly, I'm just going to summarize some of the remaining tasks. The teams all know that they've been told this. They've got to point the satellite and take a picture at a particular location, which requires them to figure out the aiming, and we'll see if they've done that overnight. They've got to take a picture of one of those blacklisted, those banned locations, which requires them to combine the fact that they need to they need to figure out how to lie about where they are or where they're aiming, and then be able to take a picture. And then there's another one as well. There's another challenge called the Iron Bank, that involves some cryptography breaking that they have to do on the satellite. They have to break some crypto properties and exploit this service on the actual satellite itself too. So lots more, we'll see if they do. And with that, I'll turn it over to Kevin. If I can push the right button, it's not F5. What's the other one from current slide? There we go.
All right, check. All right, thank you, Jordan. So in case you had missed it, hello, sorry, check. So you're probably wondering what is on this table right here, and this is actually an engineering model of Moonlighter, the satellite that's over in low Earth orbit right now. And so we started this talk about 45 minutes ago, so it's gone halfway around the entire Earth since we all sat down and started talking. So it's about 17,000 miles per hour. So it's going really quickly, and Jordan had explained really well how some of the issues and challenges actually that are faced with the satellite moving that fast. You have to plan way ahead of when you have that limited contact window with Moonlighter, and so that makes it all the more challenging as the first CTF in space. So again, this is a engineering model of it, and I have some more breakout of it. So here is a chart that shows Moonlighter a little bit up close. Again, we launched and deployed this summer. We have good footage of that launch and deployment on our website, Hackasat.com, and we also have a lot of other tons of good content that describes previous year's challenges and a lot of educational material as well. Hackasat here at DEF CON is the first use case of Moonlighter, but we're certainly finding different possibilities of using it in a similar way to help us become better and more cyber secure. So here's a chart. It's a little bit difficult to read, but we have the poster of this over in the contest area where we're mainly located, so you can look a little bit closer at where each of the all the different components of Moonlighter. It has everything that's in a real satellite, because that's what it is. Its primary payload is a camera that's located on the top of it. You can see it right here. Like Jordan had mentioned, one of the challenges will be taking a photo of Earth. One of the ways you do that is by finding out where you're oriented. So in space, it's really hard for a satellite to do that just on gravity, because there is no gravity. So it uses sun sensor, star trackers to sort of look and orient where it's at, and then it sends commands to the reaction wheels within it to sort of go and face and point it with good accuracy. So check out the poster right next door, and just talk and ask us a little bit more about it. Essentially, it's a flying computer that's going 17,000 miles an hour away from you, so it's really difficult to operate and work with, but it still makes it all the more challenging. And here's another, more photos of it. Again, this is, that was the actual Moonlighter itself that we took photos of. That middle photo is the stowed position of, that's how it looked before the solar array panels came out. And it's important to make sure that these solar array panels are facing towards the sun, obviously, to do resource management with your battery. The next slide shows, so this is what the competitors see, but it's also what all of you can see too. If you go to Hackasat.com, we have live tracking of the Moonlighter space vehicle. We're showing like who scored points when, live updates. It also shows the next contact windows of when people are going to be able to talk to the different ground stations. So we have 4 dedicated ground stations specifically for this competition, and you can see there's one just on the very, very end or bottom of Chile in Punta Arenas, and that's just one of them. So most of them are in the lower hemisphere. It also shows the different areas where they can take photos and where they can't take photos. So definitely recommend checking out the website throughout the competition to find out a little bit more about where Moonlighter's at. Again, it has a lifetime of about 1.5 years before gravity eventually brings it down and it fizzles up in the atmosphere like a shooting star. But for now, if you want to keep tracking it, just go to our website. And to close things off, I'll invite Steve up here. Thank you.
All right, so quickly wrapping things up. A lot of good content, still a lot of competition to be had, still a lot of things we're getting back from the satellite, so we're going to have some more things to expose pretty soon. But I just wanted to give you the schedule for tomorrow. That's going to be really important. Whoops, not that. All right, so tomorrow at noon, we're going to announce the winners. So we already talked about why we're going to announce the winners tomorrow, and we can't do it earlier. But also we're going to have the game designers. We're going to have Jordan, and all the teams are going to be here. But mostly the game designers are going to talk about some of the, in more detail, what Jordan couldn't expose today. So it's going to be a really, really deep dive technically. So if you're into that, please join us. And our announcement, or the special guest, will be announcing the winners. So that'll be kind of cool also. So much appreciated for your time, and we look forward to seeing you next door.